Okay guys, today we're going to do Unit 3, Algebra Flipping of the Lesson, and it's going to be on graphing relationships. Okay, we're going to start out with an example of these graphs. Each day several leaves fall from a tree. One day a gust of wind blows off many leaves. Eventually there are no more leaves on the tree. Okay, so which one of these graphs represents this data? So what you want to do is you want to look for segment descriptions. Segments are the lines. Okay, each day several leaves fall. So when several leaves fall, you're never going to have a horizontal line because it's not going to be constant. It's always going to be going down like this. So you will never have a horizontal line on that graph. Well, which one of these graphs never has a horizontal line? Well, there's a horizontal line, and there's a horizontal line. So the only answer to that one is B. Wind blows off many trees. Okay, so that would be a downward So we have downward, we have downward, and we have downward. So this is all three graphs. Okay, eventually no more leaves fall. So again, it's going to be downward, until it stops. Okay, so which one of these graphs have downward till it stops, downward till it stops, downward till it stops? So this is all three graphs. So when we identified the segments of the scenario, which graph had all that we needed? Graph B. So let's look at that. Okay, several leaves fall from a tree. So right here they're falling from the tree. Excuse me. One day a gust of wind blows off many leaves. So we have a steeper line, then no more leaves are on the tree. So leaves are falling, gust of wind comes, blows them off, then leaves are falling, and then it stops. So graph B is an example of that scenario. Okay, what do y'all think about one here? Which graph would represent that scenario? The air temperature increases steadily. That's not increasing. That's not increasing. So here's your answer, but let's continue. Increasing, all right. Then it remains constant, remains constant. At the end of the day, the temperature increased slightly before dropping sharply. Increased slightly and then dropped. So graph C is your correct one for that scenario. Okay, I see in example 1, some graphs are connected lines, are curved, called continuous graphs. Some graphs only have distinct points, and these are called discrete. So let's look at an example of a discrete graph. We have a graph of a theme park attendance. These are the years, and these are the people. Okay? The example is showing you each year. They don't want you to break it down into months or weeks. They want each year. So they don't want you connecting these points to find out maybe what 6 months or 1 month would be. So this is an example of discrete. And here's a key word, each, that will help you whether it's discrete or not. Okay, we're going to sketch a graph. Okay, you always have your time on your horizontal. That is your X. And right here we have speed on our Y. And this is driver speed. Okay, a truck driver enters a street. Okay, time has stopped, speed has stopped. They're entering they're entering a street. So it goes up a little bit, drives at a constant speed, so they're still driving, but the speed stays the same, so that would be a horizontal line. Then stops, so speed stops, but time does not, so we need to put a black line right here because, you know, you could be sitting at that stop sign where the speed's not increasing, but the time is, so here's the stoplight, and then continues on. So there's an example of that graph. Oh, we need to back up. Is this last graph here continuous or discrete? I don't see the word each, and you can break the speed and time down, so it is continuous. Okay, so we have a bookstore. We have days, and we have number of books sold. Okay. So, a small bookstore sold between 5 and 8 books each day for 7 days. Here's my 7 days. Each tick line represents one, but I only identified each other tick line to keep it clean. And I kind of put some lines here because the range between the books sold need to be between 5 and 8. So day 1, day 2, day 3, day 4, 5. As long as it's in this range, then you're good. Okay. Now, is this discrete or continuous? Well, it says each day, so it is discrete. Cannot draw or connect the points. Okay, let's see y'all do this one on your own. And look up here if you get stuck. Okay, you want your time on your horizontal, words per minute on your vertical. Okay, you need to make sure that each week that the words per minute is increasing, so it's going to go up. Is this continuous or discrete? Well, they want to know each week. They don't want you to break it down, so it is discrete. Okay. Let's skip 5 to save on time and go ahead and do number 6 here, okay? So, what we're doing on this one, guys, excuse me, is you're going to be given a graph and you're going to have to write a scenario, okay? We've got 2 different graphs here. We've got a child that's on a slide, and you can write it, you can have a graph where there's distance from the ground, time, where the child's on the slide, or you can have speed and time. So, this graph would have the child at the top of the slide, getting ready to go down, okay? Sits for a while at the bottom, scooting, and then goes down. Then the speed would be, if you're climbing up, sitting at the top of the slide, speed goes down quickly, so your segment is steeper there. So you need to write a scenario for this one. Okay, so I'm going to think of a plane, and I'm just going to describe it to you all. You all can write it down. So, what do you think the plane would be doing right here? The plane is going down, descending, and slowing down a little bit. So the plane might be getting ready to land. Okay, so they're descending, getting ready to land. Then when it's horizontal, the plane hasn't stopped. It's still flying, but it's flying at a constant speed. So they could be hovering or circling around the airport, waiting for permission to be landed. And then they've got permission to land, so they immediately go to the landing track, slow down, then eventually stop. So that would be an example of a scenario that you would have to write down by looking at a graph. All right, guys, that's it. Have a good one.